Hello, fellow ag nerds. Thanks for joining me for another episode of the Future of Agriculture podcast. My name is Tim Hamrich, and if you're interested in where innovative ideas meet practical realities in food production, you have found the right show, and I'm sure glad you're here. Hopefully you had a chance to listen to last week's episode with Brian Tischler, where we explored his Ag Open GPS open source project and the community that's being built over there, thousands of people around the world. If you didn't, I highly recommend you go back and listen to that one after you finish listening to today's episode. Today is another example of an open source project, but this one is a little bit different in a few different ways. First, it's quite a bit newer than Ag Open GPS, which has been around for years now, and it has that robust community that Brian has helped to develop. Secondly, it's focused on a different agricultural problem. In this case, site-specific spraying, or, some people might call it spot spraying or see and spray type technology. The project is called the Open Weed Locator, or OWL for short. My two guests today are leading the efforts to develop an open-source, low-cost weed detection and control device. Essentially, it's a site-specific spot spraying system that you can make yourself for around $400. Right now, it's only designed for fallow-type weed control scenarios because it sees green and sprays it, so obviously you wouldn't want that running through a growing crop per se. But I think with the open source community that they're developing, it's only a matter of time before they add artificial intelligence to identify and spray specific weeds, or perhaps even some sort of non-chemical weed control like electricity or lasers even. As you heard Brian talk about last week, the opportunities with low-cost hardware in the hands of an innovative community are really incredible. As if that's not cool enough all on its own, we also highlight another project in this episode, which is Weed AI. It's basically an online repository of weed imagery in crops. And this gets back to something we've talked about numerous times on this podcast, which is we need quality data sets for companies to develop artificial intelligence. And Weed AI is doing this in sort of an open source way, which I think could have huge impacts on helping new innovations come along in a way where they have access to an open source data set like this. We talked about it just recently in our robotics roundtable. Well, I'm sorry, I got all the way into this introduction and I haven't even introduced our guests, but we have on the show today Guy Coleman and Willam Salter. Guy is a PhD student at the University of Sydney in Australia and also a Fulbright Future Scholar currently based at Texas A&amp University. His research focuses on the interaction between artificial intelligence for weed recognition and plant morphology in large-scale production systems. Guy also has experience in alternative weed control technologies like lasers and targeted tillage. Willam Salter, who you will also hear called by his nickname in today's episode, which is Tam, is a postdoctoral agricultural scientist at the University of Sydney. His research focuses on several important aspects of plant and weed science, ranging from improving crop productivity to killing weeds more effectively. Willam has a keen interest in developing new low-cost tools for use in scientific research and the agricultural industry. So these two guys take us through the evolution of the Open Weed Locator, or OWL project, the importance of open source technology, not just for farmers, but also for people like them from academia as well. They'll also talk about the role Weed AI can play in the future of agriculture and really quite a bit more. One more quick note. You're going to hear Guy and Tam talk about Raspberry Pi. No, that's not P-I-E like the delicious dessert, but actually a tiny low-cost computer that is used to program OWL and many other low-cost technologies around the world. I'm going to drop into the conversation here where Guy Coleman is taking us back to the origins of this Open Weed Locator project.
I think the beginning of OWL and an open source weed detector spot spraying type system probably went back a couple of years to seeing a whole lot of how-to guides on how to build things like home automation systems. You kind of Google things with Raspberry Pi and a whole list of pretty cool projects come up, but very few of them anything to do with agriculture. So this is back around 2019, I think. And this time I was also still learning to code, but always learning to code, but so I was looking for things to do. And I guess I had the opportunity then to start developing something that was like an instruction for other people who weren't in agriculture to build their own agricultural device. And so I was writing this kind of how-to guide. I wrote most of it. And finished most of it, and then it kind of got put on the shelf a solid year. And it was only once I started revisiting it back in last year, so mid last year, I saw there was an opportunity to potentially actually make this into more of a device, like a more professional looking how-to guide. And part of it as well was using off-the-shelf components, because that's like, I can't build PCBs or like printed circuit boards. I can't do to really super complex electronics. I'm very much a bit of a hack, I guess, as you might call it. And so I just bought things that were easily available on like Amazon or eBay, things that were cheap that I could afford. And that was kind of the rough design parameters at that point. So it was a $12 relay control board, like a roughly $100 Raspberry Pi, and a cheap camera. And so just kept on tinkering on it as a bit of a side project of using some of those computer vision skills I was trying to practice. So things like green detection, simple just XG algorithms, excess green, where you just muck around with the image channels, so the red, green, and blue channels and images. And put that all together into this box and got it kind of roughly working, I think, at that point. So that was towards the end of 2020. And I think I was telling my boss about it, Michael Walsh. He's the director of weed research in Sydney. And he saw a really good opportunity for it. I think something I hadn't necessarily realized. It was a low-cost, simple weed detection device for fallow situations that use cameras and image-based approaches that were coming and are becoming much more popular. And so I think it was that recognition of the impact it could have, and then his interest and strive to then see this through to the end, that kind of renewed, I guess, my interest in continuing it and developing it. And that's the point that the TAM got involved. So that's the start of this year now. TAM's been fantastic about kind of contributing in that way of getting across the line and bringing that kind of open source, open access science perspective to it as well. And that kind of brings us to the point now that we did go through a bit of a testing as well. So earlier this year, we're out in a few farms in southwest New South Wales. So that's kind of eastern Australia, near just about a few hours from Sydney. And the idea being, we just wanted to check to make sure this thing could do as it said on the box. So it could detect weeds in a variety of fallow conditions. So different soil backgrounds, different lighting, different stubble loads as well. So that was where we did the testing, validation, and then finally the writing over the past few months as well.
Cool. And William, give us your vantage point though. So he kind of mentioned that he brought it to you when it was getting started, but really needed help finishing it. What stage was it in when you kind of got involved, and what attracted you to the project in the first place?
I was very lucky. At the end of last year, I was finishing up my second postdoc at Sydney, and I had worked on a couple of projects where we had been building low-cost tools for plant phenotyping. So I guess to look at photosynthesis cheaply, and also to measure the light under canopies cheaply as well. And I was lucky that, Michael had sort of already seen the value in the OWL project and approached me to see if I would like to be involved. And I mean, the work that Guy put in before that, he really laid the groundwork for where I picked it up. I mean, we had a workable device at that point. It was about fine-tuning and I guess really testing and writing things up when I joined the project. And I guess I also saw, rather than just it being an open source tool, I also saw it as being an educational tool for farmers who may not have been exposed to such technologies before. I think we can probably all agree that this is where weed control is going in the future, with more smart weed detection systems and more targeted weed management strategies. And so, rather than just having a GitHub page which just has the code, we really, jumped in on the educational side of things and actually made it a fully fledged, almost like just a website with instructions on how to build these things. And we hope to continue that moving forward and continue to develop with the help of the agricultural community.
Great. And Guy, was all the hardware here, was this all just off the shelf hardware that you could kind of buy and put together?
Absolutely, yeah. It's all just cheap stuff you could get from your local electronics dealer, because that's where it was just available to me. So eBay was a great spot, but equally there's a few shops in Australia that we could buy it from too.
And so on the website, do you list not only the code if they want access to it, but also where to go find each piece and how to put it together?
For sure, yeah. So we have a full table. So every single component like down to the individual connections. So kind of plug and play connections we try to minimize the amount of soldering and specialized tools you need. And all those are listed there. There are links to the Australian websites, but they list the part numbers, and then you can obviously find them in your local area, or they're just mainly suggestions just to show what the details are. But obviously people would potentially have their preferred retailers wherever they are.
Okay. Well, this is great because this is very helpful. So we're talking kind of stage one. You are sort of scheming this, and then you put together basically a prototype. And then, you get other people involved, including Willam here, who kind of helps you really hone the technology to where you want it. At what point does it become an open source project and not just a couple of guys tinkering?
I think, I had the discussions, I guess, with Michael, the director of Weed Research, about which way do you want to take this? Because, as I'm sure you'd be aware, there's lots of people jumping on this kind of technology to make some money. And I think that kind of discussions, probably end of last year, where I was like, look, I really want to make this open source. I want to be able to publish it. To me, the value is in having others build it. I guess I'm at the point where I'm fortunate I don't have dependents or people that need to survive off a more than a grad school income. So I'm privileged in that sense. But yeah, I guess that's the point. I've made the decision. I want to publish it, make it open source. And then that was kind of the start of it. And then, as Tam's mentioned, it kind of developed once Tam came on to more of an educational piece and kind of expanded that open source approach.
And Willam, talk about the educational piece. So you've got the prototype, the code is available, it's open, whoever wants it. What's the strategy or what's the approach to really, making it an effective educational tool?
Yeah, I mean, look, the main thing that will make it effective as an educational tool is just getting it into the hands of people who need to learn about it. And so we're using Twitter and LinkedIn to our advantage there. OWL has truly fled the nest. It's out in the wild now, and we have had some really good feedback already. That's just been a few weeks that the GitHub has been live, but we have had a large following, a lot of people interested in learning about this technology and wanting to get down to their electronics store and buy the hardware to put this piece together. Another part of the thing that will make the educational side of it a success is the fact that it is all very low cost. However, it is customizable as well. So people can learn at their own pace. They can just follow our instructions exactly as we put them down on paper, or they can sort of customize it to their own use as well.
I have never built something like this. It's really cool. I'm definitely a fan more than a practitioner, but I am used to putting things out into the world for free, and it's exciting who it reaches, but it can also be daunting on some of the response you get. In my case with a podcast, either people wanting to come on or talk about the topics we talk on here. It's a little bit difficult to keep up with all that. Like you said, if you're doing it for free. How do you all handle that? Is that part of your job, in working for the university? And maybe this is a broader conversation about how do open source projects become a thriving community instead of all of the work ending up on the people who sort of started the project?
Yeah, so it's a good question, I guess. And something I'm probably trying to reckon with at the moment about allocating time to the project and developing code for it. So personally, I guess it's just trying to limit my own time I spend on it. And to me at the moment, it's about probably getting enough people behind it initially to get it into its own kind of community. So probably the way I see the development or the effort curve potentially is put the effort in early, develop that community, and then hopefully it starts to kick off. And what we've seen already in the last kind of week of having it open, so just on the GitHub issues page, we had a couple of people conversing about their own experiences building it already. And so that does already take the load off Tam and I trying to build one or trying to keep up with that, answering those questions. I think longer term in the sense of developing these open source communities, you do see examples, really fantastic examples. You might have come across AgOpen GPS and Brian Tischler from Canada and that platform or the discourse they have there. So AgOpen GPS is all about developing open source GPS driven tractors. And so people put up their experiences, people ask questions, and it seems to have reached that critical mass of people where obviously Brian works hard in the background, but it's all those questions, all those answers, those shared experiences tend to be evenly distributed over a larger group of people. And so that's probably what I'm what I'd be looking at as an example of a good ag community of open source development. But I'm not sure I have the answer to develop a community, so it's like a manageable amount of work for everyone involved.
William, anything to add to this, to the community building part?
Yeah, I mean, I guess like what we've talked about so far is very much online communities of people who are already quite tech savvy. What we'd also like to do is get the OWL into the hands of community groups. And had it not been for the latest COVID outbreak here in New South Wales, we had actually planned some workshops with some groups, some farmer groups in New South Wales, to go through the building process of OWL. Our plan was to bring some pre-3D printed parts for them to use and all the other hardware that they need to put together a basic OWL unit. And so hopefully we can continue those sorts of workshops down the track as well, to get it into the hands of people who would probably benefit from the educational side of this project more than people who are already willing to go down to the electronics shop and are quite sort of familiar with a soldering iron.
And let's talk about that. You know, if you are successful in your educational aspect of this, it's not so much like world domination through OWL, but it's a different way to think about ag technology, right? So maybe talk about what you just mentioned, that these are the people you're really trying to reach because they'll benefit from the education of it. How will they benefit, and how do you see that playing out, you know, for people like that?
Yeah, I mean, like the benefits of OWL are sort of quite a few fold. The first off is obviously just with any site-specific weed control unit, you're going to get cost savings in the long run in terms of chemical usage, and you'll be more environmentally friendly as a result as well. And so, yeah, like educating the farmers about site-specific weed control will have those benefits, but it will also, I guess, open a new world to them where they can build their own equipment and fix it and customize it themselves as well. And that just might not have been something that they were aware of before. Like lots of technology, the vast majority of people will just go out and buy something off the shelf. If it breaks, they will go out and buy a new one. It's probably not quite the same in the agricultural space. Growers tend to be they're pretty good with their hands. But with these new technologies, I guess we do face the problem of going that same way, that you've got this black box that you stick on your sprayer, and if it breaks, then you're at the mercy of a company to fix it.
And in your opinions, how attainable is it for the average, you know, farmer or anybody? I'm not trying to single out farmers, although that's just the context that this would be in. Farmer, agronomist, person that works in agriculture, to learn the skills to actually contribute and modify and evolve a project like OWL, if they're starting without, you know, those programming skills?
I guess it's designed, the way we wrote the instructions and the guides were really to target so anyone could put it together. It was meant to be, you didn't need any really prior experience in electronics. You have to have a soldering iron, but you can get those fairly cheaply from your local hardware store. So it was trying to make it as simple as possible to put together. So it's mainly just about connecting wires here and there and keeping the diagrams straightforward. So on the contribution front, I think there's also the opportunity is not just necessarily in the code or the actual hardware in terms of improving that, but it's in the use cases, it's in the different types of algorithms we might use, or what farmers actually need one of these items or like one of these devices to actually do. So I guess a good example of that, I was speaking to a farmer up in Dirranbandi, so southern Queensland, I think, just a few hours north of the border with New South Wales in Australia, and he was interested in using it for his cotton. And I guess that was like a use case in terms of adding GPS speed control or these other dynamic delay control that we hadn't yet implemented. But by speaking with that guy about what he had existing on the vehicles or the implements and the equipment he had, found a much easier way of developing these dynamic speed control algorithms where you can just take the GPS data and speed data straight off the tractor that already has GPS there. So I guess that's why that's fairly obvious and first step. It's a great example, I guess, of how we can speak with growers or have people use these and contribute in not necessarily just the software and the hardware sense, but the use case or the contextual information about how these devices can be deployed more effectively.
And in its current form, What is the total cost of the parts of the hardware? If someone was going to assemble one themselves, what are they going to pay just in parts to get it built?
Correct me if I'm wrong, Tam, but I think it's about 100 odd, this is in Australian dollars, but it was $100 odd for the $120 for the Raspberry Pi 4. Then I think the camera is roughly 99, 100. The other major part is the relay control board, which is about 12. And I think a few of the connectors are fairly pricey, just the ones we chose because they're weatherproof. I think they're about $20 to $30. I think bringing it all together, you end up with about a $400 unit. So it's considerably cheaper, low cost, I guess.
Cheaper than a really basic drone. I mean, really. Very, very cool. Well, let's continue on with OWL specifically. I love that example with cotton that, they could find use cases. And then, you've got the community that's talking back and forth and saying, well, if we could just get it to do this, then I could use it in this other use case. And somebody else I could envision saying, oh, yeah, well, we can do that, a really easy way. And sort of that's how these things get developed. My understanding is if you wanted to, you could take OWL, let's say, Guy, you wanted to after your time in the US here, and commercialize it, and sell a product using this open source technology. It'd still be every bit as open source and available, and you don't have to, make the community mad. You just kind of offer it for people who, they want the sales and support and service and all that stuff. You could essentially do that, and it would all still be open source. Is that right?
That's correct. So the licensing is always a big part of open source. And probably one potentially misconception with open source is that open source is always free. So in this case it is. You can go up there and you can get all the code and all that for free. It doesn't necessarily always have to be. It's just about the accessibility of it and you be able to see behind the scenes. Obviously, again, license dependent. But selling kits, that's all an opportunity down the future to make that process easier for people to do. And people can build off of OWL as well. The license requires people to make sure they show where it's come from and make sure they're, sharing that as what they've used, as well. Well, you can see the license specifics on the GitHub. So that's the great opportunity of open source, is that people can see how it's developed. And often, as you've mentioned, the difficult part is sometimes putting these things together and actually having the time to. So while you're sharing all your secrets in that sense, you can focus on delivering good service, delivering a good product, and then commercializing it that way and helping out people who might not have the time or want that extra support and helping those people out as well.
Well, I have a feeling I'm going to run out of clock because I have a ton of questions here, but I'll come back to something later. But for right now, I want to ask about, William, it sounds like where your work might come in as well is if you wanted to go beyond just green, brown, sea green, spray it. You could do that. Let's say you wanted an algorithm that trained it to only spray Palmer amaranth, right? You need to train, an algorithm to be able to spot Palmer amaranth. Is that a software problem more than it is a hardware problem? I imagine you've got the computer vision hardware that you could buy off the shelf, I would imagine. Is it more of a software issue?
Yeah, certainly. The hardware of OWL could conceivably run algorithms such as that at the moment. However, it's the training of those algorithms that's a big bottleneck, but that's certainly an area that our group is working hard in as well. It involves humans telling the computer what is a Palmer amaranth weed and what isn't. And that is quite time consuming. And one of the ways we're getting around that, and Guy can speak more about it, is the Weed AI platform, which is another open source tool specifically designed around training these machine learning algorithms to better detect and identify weeds in field.
And so talk about that, Guy, if you don't mind, because my sense is, I don't know this, that basically it's almost like crowdsource images of weeds so that you can have enough images to train an algorithm to know when it's seeing that particular weed. Is that right?
Yeah, that's pretty close to what we're doing. It goes back to the difficulty of capturing weeds in all their diversity of appearances and lighting conditions, soil backgrounds. It's a real difficult part of that detection process. And what we saw was this massive bottleneck, as Tam mentioned, was that slow process of annotation of telling the computer what the weed is or what the crop is. And by, as you mentioned, crowdsourcing that or encouraging others to open source their own data sets, it not only lets people like the maker community or the open source community try and develop their own algorithms for their own problems, say, in their own fields. But it gives us this opportunity to start designing algorithm architectures. So the way these algorithms put together, so different like structures and different functions coming together, the way you organize all that in like a recipe, I guess, is enabled by having this large data set of images. So I guess going back to other industries, so if you look at like object detection, so things like your mug or your computer, cars, people, those large data sets were developed in late 2000, so 2009, 2010. Professors from Stanford, so I think FoA Lee was pretty visionary in this and developed this large data set called ImageNet, which scraped the internet of all these images. And it kind of filled this gap in these new algorithms called deep learning algorithms that were so hungry for data, but they could outperform what the algorithms had previously worked on these data sets. And we're trying to do that, I guess, with weeds. So the current algorithm architectures are all based on these large open source data sets for everything except weeds. But if we can get these large data sets of weeds together, then we can potentially start developing architectures that are specific to weeds and that might actually do better, and start exploring these more research computer sciencey questions that weren't previously possible with the data that was available. So it's probably that two-pronged approach. It's about getting people to start contributing and finding weeds in the whole variety of scenarios they often present, and also about opening up these new architecture, research, development questions as well.
Mm-hmm. And so the reason you can't just scrape the internet for all images of weeds, is it an image quality issue? There just aren't enough quality images out there to do it similar to the way you mentioned they did it with other objects?
Yeah, it's just that there's not that firstly the quality. So there's very few images of each instance of weeds, so each species. Then you've also got the impacts of growth stage and how the weed might look, say, in a cotton crop or like a corn or a bean crop like soybeans. So it might grow differently to, say, your cotton crop, because the row widths might be different, the background textures might be different, the nutrient applications, the herbicide applications are all going to change. And just scraping the internet for that just doesn't, unfortunately, seem to provide that data or the level of annotation quality you need. And then there's image quality too. Like there are weed or crop photos out there, but they might be from a distance, unknown angle, that might not sort of have the right resolution to really see the weeds in there so you can accurately identify them, even being a human, let alone a machine. So that's probably the tricky part of that. Whereas if we target a species, and part of Weed AI is about standardizing metadata. So we can report things like soil texture, color, background conditions, lighting, angle, camera type. Then people can start to answer questions and probably develop new questions as well based on that metadata, and fill in the gaps in their models where it might not be performing.
And what are the forces working against this? Like, this just seems so much better for everybody to have an open data set of things like weeds, but also, other things as well. I'm thinking pests, diseases, crops, even, to have like an open data set that everybody can use to develop technology around. The one obvious force working against it is a private company wants to keep this as their intellectual property to make money off of. But are there other forces as well that work against sort of this shared data set so that we can use it for technology?
Yeah, I mean, as I said, the image set is a bottleneck, but in terms of actually obtaining the images, but labeling the images correctly so that we can train the algorithm with those images is, I guess, the largest bottleneck, because we have to show people how to do that. But I mean, that is something that we are working on. And just in the past couple of weeks, Guy has been running some online workshops showing interested parties how they can label their images and get them into a format that works. So with all the correct metadata on the lighting, crop type, location data, all that stuff is there and correct when it is uploaded to Weed AI. So that, I mean, we do have a review process, but it keeps that review process fairly short if the users already know how the system works and what we expect when a data set is uploaded to Weed AI.
Well, how do you continue to incentivize people to contribute, to get them excited? And this gets a little bit back to the community building aspect, but just in general, what have you found turns a light bulb on, and what type of person's interested, and what gets them excited about this project?
So I think that the type of people interested are often those, initially at least, so this iteration, is the people that probably have some interest in electronics at the moment, and those that are also looking for site-specific weed control because it's agriculture, they're interested in new technology, and they want to try something that's already out there. And I think to encourage people to contribute and to keep giving, I guess, to this open source initiative, probably the best thing that I've found personally about this industry is that you can see your results of your coding or your development in a field setting the next day, or you can see someone else using it. And I think that's really rewarding because you can see how it will benefit the grower, it benefits the crop. And if you're reducing inputs, then there's a whole range of downstream benefits to the environment too. So you can see your input being effective on the ground, in the field, and with people that are really going to appreciate the input too. So while, of course, all open source projects are fantastic, but you can see, if you contributed to TensorFlow, like a very small part of TensorFlow somewhere, sure, people are going to appreciate it. But it's difficult, I guess, to see potentially the impact it has in the field. Whereas here, it's, I guess, we're hoping that that's really on the ground impact, having farmers use it and seeing the results of your work in real life will bring people in.
Yeah, I guess going one step further than that, we hope that people who decide to build an OWL as it is at the moment benefit hugely from it, and they feel happy with their success at building it as we've seen it. But what we really want to see is people taking it that step further and using what they've learned in the process of building our OWL unit and using it to, say, develop new algorithms that work on their farm where others may not, and adding them back into our GitHub page so that we can share those algorithms with other people in the community as well. And like that's something we really want to do is share the success of OWL with everyone else. And hopefully those success stories will inspire other people to take it on as well.
Maybe for the last few minutes, let's kind of take it big picture here and look out forward. What do you see for the future of open source ag tech? Certainly, there's a lot to be excited about in technology in general, especially as the costs of some of the hardware go down and maybe we get something like Weed AI that has these databases of images that can be helpful. To me, it would seem logical that we'll see more and more of these open source type projects, but talk to me about how you see it playing out and how you see the world looking differently when it comes to open source ag tech.
I guess I'll approach it from a scientific perspective. I just see everything going more open. Publishing, we've got more and more citizen science projects where we're getting people who historically wouldn't have had access to scientific education being involved in science. And I think, open source ag projects do that for agriculture. And they expose growers who may not have had access to scientific practice or technological tools such as this in the past, and get them in on the ground level and teach them whilst also providing them a tool that will benefit them in the long term. And so I hope to see more and more projects like this in the future.
I think for me, probably from the tech, the industry perspective, it's the big picture for these type of things. I think we will see more open source projects and hopefully contributing to more interoperable or better standards that enable communication and sharing across either different industries, different manufacturers, and by making everything open source and viewable, people can start to, see the connections or relationships between different technologies that might not necessarily have been visible previously because it's all closed up behind closed doors. And I hope there's a more of an understanding maybe, or like a more appreciation, I think, of the benefits of open source, and maybe kind of to do away with some of those myths about open source always having to be about like data privacy, or open source meaning you have to compromise on profit or compromise on other things. Like there are ways, I guess, to incorporate open source and the way of incorporating the style of development and also incorporating those other fundamental parts of being a profitable company or making sure data privacy exists. So I think there's hopefully changing that perspective on open source enables these new projects to flourish, I think would be fantastic for the industry. And hopefully you'll also tap into a whole new type of people that might want to start developing and start providing solutions too. So without that code base, without that database there, you really can't access these people that were otherwise focused on autonomous vehicle data sets or autonomous vehicle code or machine learning code. And so that's probably the other major benefit and hopefully shift that we start seeing.
Well, thank you very much to both Guy and Tam for being on today's show. How could you not want to root for these open source projects to be successful? I mean, I am loving what they're doing, as well as a lot of the other open source activity I'm hearing from out there. I am excited to see this be a growing part of the future of agriculture. I'm going to include links in the show notes for the OWL GitHub, as well as the Weed AI website and their Twitter accounts so you can follow along. I'll also include a link to a cool video of this technology in action. So great stuff here, and I hope you're as inspired by these stories of open source ag tech as I am. Before we close out today, I do want to give a quick plug. I'm hosting an AgTech Investor Roundtable in a couple weeks. That's Tuesday, November 9th, 2021. Joining me will be some former podcast guests who are AgTech investors, including Francisco Jardim, Sarah Nolette, Mark Kahn, and Jeanette Barnard. I'm super excited for this. It's happening live, and attendees will get the chance to interact and ask questions as well. It's open only to members of the FoA community, but you can sign up for that for as little as $5 a month and cancel it anytime if you really want to. Sign up and get all the details over at patreon.com/agriculture. Thanks so much for your time and your attention. I never take it for granted. I'll be back next week with another story of ag innovation.